Today we'll take a closer look at the vectored mode of the mtvec CSR and how it benefits the handling of interrupts. mtvec stands for Machine Trap Vector CSR. It tells the CPU where to jump on an interrupt or an exception, as we have seen before. There are two fields in the mtvec CSR. One is the base field, which has the base address of the trap handler, and the other is the mode field, which controls the addressing mode of the mtvec CSR. The lower two bits of the mtvec CSR constitute the mode bits. The mode bits have two valid encodings. A value of 00 indicates a direct addressing mode of the mtvec CSR. A value of 01 indicates the vectored addressing mode. In the direct addressing mode, all traps, exceptions, and interrupts go to the base address specified in the base of the mtvec CSR. When running in direct addressing mode, if there is an exception or an interrupt, the PC gets redirected to the base address specified in the mtvec CSR, and the handler execution begins at this address. In the case of vectored addressing mode, all the exceptions go to the base address as before, but the interrupts get their own entry point based on their interrupt ID. The entry point for each of the interrupts is calculated by the sum of the base address, which is programmed in the mtvec CSR, and the interrupt ID of the interrupt left shifted by 2. Here is an example of a possible handler implementation when the mtvec is in direct addressing mode. We can see here that the base address of the handler has been written into the mtvec CSR. Notice that the mode bits are 0, which indicates that the mtvec addressing mode is direct. In this case, whether the CPU encounters an interrupt or an exception, it has the same entry point in the handler. The handler now has to decode the mcos register and branch to the appropriate handler. For example, in this case, we see that the handler first checks bit 63 of mcos, and if it is set, jumps to the handle interrupts routine. And once it is in the handle interrupts routine, it compares the rest of the mcos bits with various interrupt codes to jump to the appropriate interrupt handler routine. Now, this approach for a handler is simple but time consuming and slower for interrupt heavy systems. Let's see how the vectored addressing mode makes it better. In the vectored addressing mode, before we write into the mtvec CSR, we also append the mode bits to the base address and then update the mtvec CSR. When the addressing mode is vectored, when the CPU encounters an interrupt or an exception, it has different entry points. For example, if the CPU encounters an exception, it always enters into offset 0 of the handler, where the handler code just jumps to the handle exception routine. If the CPU encounters an interrupt, say a supervisor mode software interrupt, which has an interrupt ID of 1, then it enters the fourth byte in the handler, which is just a jump to the software interrupt handling routine in supervisor mode. Similarly, if the CPU encounters an M mode software interrupt, which has an interrupt ID of 3, it enters byte 12 of the exception handler, which is simply a jump to the M mode software interrupt handler. This approach reduces the dispatch overhead and it improves the interrupt latency. It also has the advantage of keeping the interrupt table compact, where each 4-byte offset in the interrupt table is simply a jump to the appropriate interrupt handling routine. In the next video, we'll take a look at an example of vectored addressing mode in the mtvec CSR by writing a simple interrupt test.